Alright, welcome to the second part of section 3.3. I just didn't want the videos to get too long. So in that first one, what we saw was how to manipulate equations so that we can see the vertex and then identify the axis of symmetry and whether it's concave up or concave down, and then draw a quick graph of it. There's some other questions too. So for this part 2, our first example, I'll say example 1. This is what the question says. Describe what happens to the graph of f of x equals x squared. Actually, they work it like this. Let me word it more exactly. They say what happens to the graph of x squared, and they say the function notation to the function that they're going to do. For f of x is equal to negative x squared plus 4x. So ideally, when we look at this right here and in the future, we see this as a quadratic function. We see it as parabolic shape, and our job is to determine, what the vertex is and all that other good stuff. We should recognize that it's a quadratic because the highest power going on, as we look to what they call the leading term, it's an x squared term. That's going to be a parabola. So that's the first thing that we realize. Second thing is that right away we know about concavity. This thing is concave down. It is going to open up in the downward direction. They're using the term concavity because that's what's going to be there when you get to a calculus test. There's a second derivative test that tells you whether the graph is concave up, concave down, and exactly where it switches from being concave up to concave down as we look at polynomial functions. And so they're trying to get the language in there early, but we know the graph opens down. What we don't know is what the vertex is, and so we can't really describe anything. So what we would do is we would do the same thing that we were doing in other areas. We would isolate the x terms, and in this case both of them are the x terms. We would make sure that it has a coefficient of 1, and it doesn't. So the next thing that we would do is we would factor out the negative and get x squared minus 4x. Now leaving myself some space because you know the next step. The next step is to add something that's going to make it a perfect square. Well, half of the middle term, half of 4 is 2, squared is 4. Now, what did we really put on that side? Because whatever we really put, we got to put the opposite on there. What we really put was a negative 4. See this? I'll do it in red so that it stands out. See this negative coming to hit this 4? It's going to make it a negative 4. You're going to get a negative x squared plus 4x, which is great because that's what we started out with. And you're also going to get a minus 4. So what do we need to offset that? Well, we need a plus 4. So it may bother you initially to see the plus 4 and think, well, that's not balanced. It is if you have the presence of mind to consider the negative. This is why we're teaching it, or having you exposed to this, is because it gets you to really think. So what do we know? We know that this is negative x minus 2 squared plus 4. And so what do we know? That this graph is shifted 2 to the right and 4 up. It is reflected in the x-axis. That's maybe what they say. Or it's upside down, right? They'll give you some choices there as to what to say, but it's opening down, right? It's a downwards opening parabola. And so that's how we can know more about it, is by doing the same thing we did in last videos, but it's a different style of question because they're not asking us to graph it. Another question that comes up, and it's a really good one, and there's a couple, I think, at the end, maybe 3. So we'll do one example of them, and note that there's more in the textbook and the e-textbook. There's also more in the videos as you want to go there. But what's going to happen is they're going to give you a graph. They're going to give you a graph, and in this graph they have the vertex of the parabola, and they actually label it out as negative 4, 4 in terms of put the ordered pair in there. And we got a parabola that's opening downwards, and it's crossing the y-axis. Sorry, that doesn't look very good. Let me just make that look a little bit better. Okay. So we got this thing, and it's crossing the y-axis here at the point 0, negative 12. And they give us that point as well. So let me clean this up just a little bit. And so they're going to give us a second point that's on there. And here's what they say. Find the equation of the quadratic function that has this graph. Okay, and so how do we do that? Well, pretty easily. We know that the general form is f of x is equal to some number, x minus h squared plus k, and the vertex would be at hk. So for us, what we know is, well, we don't know a, so I'll leave that. But we do know the coordinates of the vertex. We know that this is x minus h, so x minus a negative 4 is x plus 4 squared plus 4. Okay, x plus 4 squared plus 4, and we're right there. The next thing that we need to do is figure out what a is, and that's why they give us this other point. We wouldn't have needed to know the 0, negative 12 unless it was helpful. And here's what we know. We know that f of 0 is equal to negative 12. So what does that mean? Well, f of 0, negative 12, is equal to a times 0 plus 4 squared plus 4. Or negative 12 is equal to a times 4 squared plus 4. Or negative 12 is equal to a times 16 plus 4. Remember, we need to know what a is. So I'm going to rewrite that as 16a then, and I'll subtract over 4 is equal to negative 16, and we find out that a is simply negative 1. We didn't know that. We weren't sure about that, and if they had picked any other y-coordinate than 0, negative 12, any other y-intercept, let me say it that way, then it wouldn't have been negative 1. And so you have to solve for it every time. You can't just assume. And so now we're finished, because what we needed to know, as we went in here, we needed to know a, h, and k. Now, h and k, we come in here in red, these were known right away. Because we knew the vertex was negative 4, 4, we knew h and k right away. We did have to work for a. And so we come in here with our knowledge of our work and say, oh, this is just negative x minus h squared. Oh, sorry, not h. We know what h is. H was negative 4, so this is x plus 4 squared plus a 4. And that's what you're going to type in there and get full credit in that whole example. Okay. Okay. Let's take a look at one last example. Example number 3. So f of x is equal to 3x squared plus 12x minus 3. And they would like to know, does this have a min or a max? Well, let's take a look at it. It's definitely a quadratic function, and you can tell whether the graph is opening up or down by looking at the coefficient that's on the x squared. You don't need to go through the big process to know whether it opens up or down. Because that 3 is greater than 0, this thing opens up. Now, if it opens up, the vertex is at a maximum or a minimum? Oh, certainly, it's at a minimum. So this thing has a min. So the right answer to this question, if I put it below, is has a min. Then it's going to say, for what x value does it obtain a minimum, its minimum? And what is the minimum? And so they just want you to get a realization of what you're finding. You're not just finding a vertex. If you look at this arbitrary one that I've drawn right up here, whatever this vertex is, x comma y, x is where the minimum's happening, y is what the minimum is. So it's as simple as finding the vertex. So what do? Oh, you just go find the vertex. How do we find the vertex? Same way we have in intermediate algebra and throughout this section. We got to recognize that we isolate our x terms and factor out a 3. We got to ask ourselves, what would I have to add to create a perfect square trinomial? A plus 4. Half of 4 is 2. Squared is 4. So we've seen that a lot. Now what did we really add? Well, we really added 12, so I got to take off 12. And if we continue the process, f of x is equal to 3 times x plus 2 squared minus 15, we can realize that the minimum happens when x is equal to negative 2. And the min is negative 15. That's the smallest that function will ever be, because it's going up from that negative 2, negative 15 point. The moment you know its vertex is at negative 2, negative 15, and that it opens up, that's its maximum. Its minimum. It would be a maximum if it was opening down. So, for example, this last one that we did right here would have a maximum. Of course, we can see it right there. It's opening down. What is the maximum? The maximum is 4. When does it occur? When x is equal to negative 4. So we can get some really good information there. So add that to your 3.3 mindset, and allow that to govern the homework in there and help you, support you through that. So if you have questions or concerns, reach out, let me know, and we'll do our best to handle those.